All right, if you're having trouble remembering how to find a function, here we go. We're going to do number one together here. So the question is whether or not this is a function, and there's two ways to think about it. The first way is to think about what we call the vertical line test. So if I take a vertical line and I drag it across my graph, it's only going to hit one dot at a time as I drag it across, which means that for each one of the things that are on the input axis, which is the x-axis, there's only a single output. So for this input of -1 here, there's a single output of positive, it looks like 5. And so in this case, every input has exactly one output. That's what makes a function. And so this one is yes, it's a function. If yes, I need to give the domain. So the domain is the set of all inputs. So I'm going to find all my inputs by checking where each one of these dots is above, or each one of these points is above the x-axis. And so this one is at -6, this one's at -1. Here we have +4, and then positive, it looks like 9. And so my domain, and remember you got to use that set notation, which looks like this, is -6, -1, 4, 9. Okay? And so I'll try and now look for the range, which is on the y-axis. That's the outputs. So I have, it looks like 2, 4, 6, 8, +7, sorry. And then this is +5. This one hits, whoops, that was weird. This one hits at +3, and this one's at -1. So again, I'll use my set notation, and that's -1, 3, 5, and 7. Okay, so major themes here is when you're looking at a function, you have to make sure that each input has exactly one output, and you can test that on a graph by using the vertical line test. In order to find the domain of a function on a graph, you figure out what the x's are for each of the points. To find the range, you figure out what the y's are for each of the points. And recall that you don't have to repeat numbers in either case. So if in the range there are 2 points at +3, you only have to write 3 once for the range. And that's it.